Okay, I think we will start. Um, the last week, we just try to understand how the Spark will allow us to read the data that is existing in our data lake storage account. And to some extent, we tried little bit transformation options to see that um, to introduce the key components in the Databricks, basically what is data frame and how the source data existing in the data lake storage will be converted into Spark data frame, because each unique data that we are dealing in the Databricks we are calling internally as a data frame. For that we need to use the Databricks Spark code to read the actual file, the physical file existing in the data lake storage account into data frame. Then we started to see how we can select individual columns from that data frame and how we can create the temp table on top of the data frame. Then using the temp table, we try to create one of the reporting table using the Spark code and the SQL code. Then how physically we can write it back into the data lake storage account. So this is and all very basics of the Databricks Spark. The only one thing I want you to remember from this one is any data, okay, the data can exist inside the Azure. Okay, that's what we are dealing at the moment. We are seeing the daily pricing data that is existing inside the Azure. Even the data can be existing outside the Azure as well, can be able to read by Databricks using the Databricks Spark APIs. We are calling it as the read is basically a reader API, and it has got some specific syntactical options that we need to follow it. First, always we need to do is that we need to get the data as a Spark data frame format. Then using the additional Spark libraries, we can able to do the necessary transformations. Ultimately, what I am trying to, my objective here is in the Databricks, you need to aware of it, and the Databricks basic components, you need to aware of it. If a given data set, how will you read that inside the Databricks, and how will you transform the data inside the Databricks, and how will you write back the transformed data inside the Databricks? That's all I am trying to teach you. We have seen all of them in the very rough way. I think we need to have proper coding for that one. So the same code, I am going to rename it today. We will see the way how in the real-time project that we develop, not hard coding some values and not passing the folder path directly in the code. I do not want to do those things. I'm going to modify the existing code, because still the APIs and the functions that you are still getting familiar, having the existing code is okay for the time being. You need to work on it and just try to modify it. Slowly the keywords started to come. Even some of the keywords I couldn't able to even remember. I will Google it actually. Even you will see today some of the keywords. I try to Google it and bring it into here. This is the programming language. It is little impossible to remember every keyword existing in the Databricks Spark code. So what I am going to do is that here my objective is, we have got the landing daily pricing. We have got 1 year worth of the files, and inside the same data lake storage account, I created one more container called data lake house. Okay, so this is exactly the data lake that we built as part of the Azure data factory. Inside any data lake sorry, you always will have 3 layers: the bronze layer and the silver layer and the gold layer. The bronze layer is the first layer where you bring all of your source data, and the silver layer you transform your data, get ready for loading into the gold layer, and in the gold layer we will have the final output. So anywhere you are developing the data lake, it follows the similar architecture. So I would like to bring back this landing daily pricing files into the new container that I have created, the data lake house, under the bronze layer. That's where I would like to bring it, all of the files, okay, not dealing with only one file, all of the files I would like to bring it. So the first part is spark config. I have just deleted the storage account keys. The same two statements that I have given in the existing code, if you run it, it will establish the connectivity to your data lake storage account. And we have seen about the DB utilities command, Databricks utilities command, to browse through what is existing in your storage account. So it's displaying all of the three containers here, sorry, three folders under the landing folder here. Now my objective is, in this one, I would like to read all of the files existing in this daily pricing folder from the landing container, and I would like to move that into the data lakehouse container, that we newly created it, and I need to move that under the bronze folder / daily pricing folder. Okay, it's indirectly we are simulating the ingestion. Even Databricks can be used to ingest the data from the actual website that where the original source data is there. That is not the normal scenario. We always use the data factory to ingest the data. The Databricks always used for transforming the data. So I'm trying to simulate little ingestion here to get the idea about how the real-time coding looks for you. Then we will do the transformation. But from the geolocation API and the web API, we will try to ingest the data using the Databricks as well. Okay, so that you know Databricks can be used for ingestion as well as transformations. Okay, so from this landing container, I need to read this daily pricing folder. Inside this daily pricing folder, all of the files are existing. In fact, comparing to learning ADF, Databricks will be little convenient because of the programming nature. The type of the work that we did it in the ADF can be done in couple of commands here. Okay, so this is the daily pricing folder, and this is existing in the landing container. I do not want to use DB utils FSLS here. I would like to assign this into the source daily pricing folder. I would like to store this into the one of the variable. So this is where all of my source data is existing. This closing bracket related to the DB utils command. So if I run this command, my source file is stored in the source folder is stored in this variable. Okay, and we try to read the source file previously with one specific file. Okay, we were trying to read only one specific file. You can read all of the files in this folder just passing through the folder. That's what I'm trying here. The next task is, from this folder I would like to read all of the files, and I would like to assign it into the data frame, Spark data frame. The Spark read API we are going to use it, and the options, the header equal to true. It is a CSV file. Instead of giving the one specific file name here, I can pass this specific variable because this is holding the folder path for my entire source files. So in ADF we try to pass the individual dates to traverse through individual files. Here it's very straightforward. If you give the folder path, it will be able to read all of the files existing in this folder into this Spark data frame. It's really, I think, around 500 to 600 megabytes of the data is there, because if you look at the daily pricing folder, each of them is 1.22 MB approximately. There are around 300 odd files are there. You can able to read all of them in one go. Actually, the only naming standards I try to introduce here is, any folder paths or file paths or table names or file names, you need to store it in the Python variable first. Don't try to hard code inside your code. That is the way in real time we develop the code. Okay, so now all of the source files are read it into the source data frame. Now I would like to write that into the data lakehouse container, and I would like to create the new folder called bronze. Under the bronze I would like to create the daily pricing folder. Okay, So now I try to introduce one more time how we are pointing the data lake storage account path. Okay, it starts with Azure binary file system storage. That's what ABFF is calling, :/ this landing is the container name, that is our source container name, but our destination container name is going to be data lakehouse. So I will make sure that I got the access to that one first actually, otherwise we need to sort out the access. So I will create the separate code. You try it out all the options while writing the code. At the end we can able to delete whichever the cells we don't need it, but while learning it you try to put everything here. So I'm trying to saying that do you have the access to data lakehouse container? Most likely we will be having access because we are using the data lake storage account key. It will have the access to all of the containers existing in the data lake storage account. So it's displaying only the folder, the reporting is existing inside the data lakehouse that we created last week to store the reporting data. So it's fine. So source daily pricing folder, in the same way you can there will be the little confusion how to create multiple cells. Why we can't write every code in one cell? It's basically logical splitting for the code readability and also code maintenance. If somebody come and see the code, they need to be able to understand it. So logically all the variable declarations you will do in one cell, and all the source file reading that you can do it in one cell, and all the not even all one specific transformation on the source file you can do it in one cell, and writing the final output into the target table you can write it in one cell. That's how we need to logically split it up. For example, we declared our source daily pricing folder. Now I would like to store this in the branch layer in the data lake storage. So instead of destination, I'm saying that branch daily pricing folder, this is equivalent to this data lakehouse. This is the path. Under this data lakehouse, I would like to create the folder called branch/daily pricing. Okay, so I'm going to read all of the files from my landing container and I'm going to put under the data lakehouse container under the folder branch under the daily pricing. Probably now if you note it down, okay, note it down, the branch under / daily pricing folder is not existing under my data lakehouse. Okay, under the data lakehouse my folder is not there, but still it's executing the code without giving the error. This is called lazy conversion. Okay, it's probably related to one of the interview questions. Every time they will ask what is lazy conversion in the Databricks. Basically it's only check the syntax of the code to make sure that the syntax is correct. While using this folder somewhere, for example, if I try to write it into this specific folder, that time only it's go physically and check that specific folder and subfolder is exist. This time it's only validating the Python or the Spark syntax. Okay, that's all it's trying to do it. So that's why it didn't give the error. Actually this process is called lazy conversion. Okay, until you are not making any specific action on that source file, it won't do anything on that specific code. If the code involves the action, then only it will physically execute that code. So that is called lazy conversion. We probably will be seeing again and again here to get the idea about it. Now we have read the source data. Now I would like to write this source data frame into this specific folder in the CSV format or Parquet format. Okay, there is the one more file format called Parquet file format. We need to be aware of that one. In the data factory itself, I would like to introduce that one, but for some reason I have forgot it. Okay, the Parquet file format is the open source format and it is using the binary storage to store the data. You can't able to physically see the actual data. It will compress the data into the 1/5 of the size of the actual files. For example, if you look at the landing daily pricing folder, each this 1.09 megabyte file will be compressed to the 1/5 of this size. As long as the size is reduced, your performance will improve, because the processor need to read less data and also write less data when the file size is getting reduced. That is the format that we are going to use. Previously, we have used one of the write command. Yes, we used this format. Okay, write df dot write option header true overwrite dim state path. Okay, I'm using the same existing code here. Probably I'll create one more new cell. Okay, while reading your source data, first instance you need to use the Spark keyword. That is what initiating the Databricks Spark cluster. But once you read your source data, then your the entire data can be referenced by the Python variable, the data frame variable that you have declared. So now all of my source files are existing in this source data frame. So what I can say is that I can say that source df dot write header is true, mode is override, and I'm going to say instead of CSV Parquet, and you need to give the right path. Okay, the branch daily pricing folder is the right path that I am giving it. It will take a little while to execute this command. If it's not giving the any error, hopefully it will run through, because it's going to traverse through all of the 356 files. It will generate so much of the data for us. Now I'm going to delete all of the remaining comments here that we previously used on the first day. What all are the options are there. While it's running, we will start to ingest the data from one of the API. Definitely it's going to take little while. It's not too bad actually. It's ingested how much data actually. Okay, very quickly it's ingested, isn't it? It's finished actually, succeeded. So if you come to the data lake pricing folder, data lake house, in the branch it created, and under the daily pricing folder, look at it, all of the 365 days worth of the files is converted into how many Parquet files? 2, 4, 6, 8, 10, 12, 14, 15 files. And you look at the total size of this one, probably it's coming around only around 50 MB. Okay, 500 MB is converted into 50 MB. That is the power of this Parquet files. But we can able to see the actual data in the CSV file. But if you look at the Parquet file format, it is binary storage. It's compressed and it converted into the Parquet format. You can't able to see it until you are writing the code here. Okay, for example, you can read the data from this written folder again using the Spark code. Okay, spark dot read dot Parquet, and you will give your branch daily pricing folder path. This is our destination. Okay, so I am giving this into the data frame branch daily pricing source df. We used it as a destination, but I am trying to read the data that we have stored in this one. Now we have created the data frame that one. So we try to display the data frame. Now it is going to display, and it won't display all of the data, but you can able to see that the actual data that we have stored is going to come here actually. Okay, so if you look at it, 1031, normally 0101 2023 will come. It is definitely including the all of the 1 year worth of the data. Even you can able to see the count of the data how many records totally existing in this data frame? Around 5.5 million. Okay, that is close to exactly the data that we loaded in the fact table, entire files. So this is reasonably, as long as you are getting familiar with this coding format, it is really very easy actually to some extent. Okay, and it's processing huge files of the data in the couple of the seconds. Okay, I don't think Data Factory could be able to write all of the files in the 19 seconds. Definitely impossible actually. So that is the power of the Databricks cluster. So this one I will be changing this one. Okay, 01 ingest branch underscore daily underscore pricing. Okay, so now we have got one main source data in the new data lakehouse container that we created under the branch folder. Okay, from this data set you can able to create all of the dimension table that we created using the Data Factory. It's going to be the very straightforward task. Even in the last code that I have given the code for how to convert this into the table, and from that table how to create the dim state table. The similar code you can write it for all of the dimension table that we created it. For the fact table, probably you need to join multiple data frames, so you are not yet ready to create the fact tables. But please practice, that is the one of the practice for you to create all of the dimension tables. After doing this one, again I will give this code set to you. Okay, so after doing this one, from this branch layer, read the entire data and create all of the dimension table from this data frame. That is the one of the exercise for you. For creating the fact table, you need to join multiple tables. That I will teach you today. Probably at the end of the today's class, you could be able to even create the fact table. It's going to be a one notebook. To be honest, actually, Data Factory, we did so much of coding to come to that level. That is the nature of that one. Okay, either Data Factory or Databricks can be used. It will be purely the project choice. But Databricks, if you are familiar with the coding, it will be more simpler and more quicker as well. We can able to do it, and there is no limitation at all. Okay, in the Databricks actually, in ADF has got some of the limitations. Okay,